Okay, problem number 17. It says, which graph represents the equation 9x squared equals 36 minus 4y squared? Okay, and then it gives us an ellipse, gives us a circle, a hyperbola, and a parabola. Okay, so let's try and get this into some sort of standard form here so that we can work with it a little bit better. So we have 9x squared. I'm going to add 4y squared to both sides. So I have 4y squared equals 36. So I just took this equation and I added 4y squared to both sides. Y squared to both sides, and then I'm left with 36. Okay, so if this were a circle, we would have x squared plus y squared equals the radius squared. And there's nothing here that we can divide by that will make just x squared and y squared. We're going to either have, 9 over 4 or 4 over 9, but we're not going to have x squared plus y squared equals some number squared on the other side. So it's not the circle. Okay, it's not the circle. That's not the answer. Okay, if it were an ellipse, right? If it were an ellipse, I'm sorry, if it was a hyperbola, if it was graph number 2, it would be x squared minus y squared equals r squared. Okay, and in fact, moreover, it would be, x squared over a, and then y squared over b. A and b could be equal, they could be different, whatever, but the point is there's a minus sign here. That's the key feature. And, in this here we have a plus sign. So it is not the hyperbola. And a parabola is y equals, some a x squared plus bx plus c, where a is not 0, b can be 0, and c can be 0, but a is not 0. And here, we don't have that. We can try and solve for y, but we have a plus minus square root, and we clearly do not have a plus minus square root, so it's not this. Okay, and by elimination, that means this is the graph. This is the graph of it. In another video, maybe I'll show you how to actually graph, a graph just given this information without having these multiple choices here. Problem number 18 says the accompanying graph illustrates the presence of certain strain of bacteria level at various pH levels, and then we have pH running along the x-axis, and then we have the number of colonies of bacterial present in the culture running along the y-axis. And then it asks us, what is the range of this data set? Usually the range is the y values, so immediately we're looking over here at the y values. These guys are x values. We really don't care about them for the time being. This would be the domain, by the way. Domain. Okay, our independent variable is domain. The dependent variable is the range. And the range we can see runs from the greatest point is 70 up here. The y values right up here. This is 70. And the lowest point, this looks to be a little bit greater than 5 over here, but here's even lower. This is exactly 5. So from 5 to 70, that's where y lives, and y between 5 and 70, there it is. Okay, I will see you in the next question.